passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself Mallesham Devasane. Here I am going to help you to understand the compiler design, which is the last session of compiler design. The topic is the code optimization, and this topic was introduced newly in GATE 2021. So probably there may be a GATE question from this topic. Yeah. So before starting the session, as usual, let me interact each other. Yeah. Let us Nikhil. Hi. Pratik. Good morning. Tarun. Good morning. Yeah. That's all. Yeah. Good morning, everyone. Good morning. Yeah, Sweta, good morning. Yeah, this is our schedule that we have, and from tomorrow we will start a discrete mathematics. Yeah, from tomorrow. Same timings. Of course, you know that how many hours it takes to understand discrete mathematics, but let me help you in minimum hours what we can do for the GATE. If you are not prepared or you want to do a revision, then this batch is going to help you. Good morning, Sneha. And in case if you are not aware of the new batch which is started by Unacademy, that is batch A, which is started on 18th June by RBR. The first subject is going on compute networks. So you may use DEVALIVE as referral code to join this subscription plan, whatever you want to take, either 1 year or 2 years. That I will help you what kind of plans we have. And this subjects DBMS, C, Math, CO already completed, and Algo completed, TOC completed, and OS will complete by today. DS completed already, and I think CD is going to complete today itself, and digital is going on. Yeah, CN will start from tomorrow. Up to today is already started, I think. Yeah. Yeah, if you want to know about my background, that I have worked in various institutes, like that I can show you here. And if you want to know what I teach, like TOC, compiler, CEDS, algo, discrete mathematics, and some knowledge on operating system too. Yeah, this is my referral code. Yeah, Mohammed, yeah, you can find out on Unacademy. I'll share in the group. Please join the Telegram. I will share the link again. Go to the link section, Mohammed Salam. You can go to the link section. You can find out the test series. Yeah. Lavjit, good morning. So remember the code DEVALIVE. Yeah, there are various classes that I have taken on Unacademy. This is the link where you can visit my profile, unacademy.com/@DevaGateCSE. Then you might use DEVALIVE referral code to access the free classes too. Yeah, if you are not using Unacademy Learning app, go to Play Store and you can install this Unacademy Learning app, and you can watch the videos using your mobile too. Yeah, I'm talking about yeah, you can go to link section, Mohammed. So why we have two different plans for the students? Because plus we deliver everything structured, and we have live interactive classes, and we will clear every doubt that you have. But still you need a guide, you need some kind of boost from somebody to prepare in right manner. So Iconic is have all the benefits of plus. Additionally, you will have dedicated mentor whenever you need to interact with educator, one-to-one interaction with educators. That is the benefit of Iconic. And additionally, we'll have separate study material, study plan for you, booster sessions, personalized test analysis, and that are the benefits of Iconic. In case if you want to know that, this is the first batch that we have started, I am talking about, and second batch is also going to start, but in this month we have started batch A. And please enroll for this course if you are started preparation for GATE. Yeah, if you want to know the plans, plus I'm showing you only for 1 year, 1.5 year, 2 years, because these are the three popular plans. Even you can go for 1 month, 3 months, 6 months, but there will be no use if you want preparing for 1 year and 1, 3, 6 months you are in a hurry to complete the syllabus, and where you will get less time to prepare all the subjects. So I recommend to go for 1 to 2 years, any plan as per your convenient. If you go for 2 years, that's 39,600 after applying my referral code. Iconic, similarly, you will have many plans like 1 month, 3 months, 6 months. Of course, here 6 months, 12 months, 24 months are necessary, where you can get at least some knowledge. So I talk about 1 year and 2 year, and remaining just look at on Unacademy what you have. And 1 year and 2 year prices you can see after applying my referral code. In case if you are aware of Unacademy Combat, which is going to happen on Jan 26, please register, and you may use my referral code DEVALIVE, which is a free combat where you can participate in questions and you can challenge, where you get less time. In 65 minutes you will have a time to have few questions. Yes. Yeah, let's begin, guys. Yeah, if you have not watched, you have not liked it, please like the session, then we can go for beginning of the session today. Are you ready? Yeah, good morning once again everyone. Yeah, almost we have completed lexical, syntax, SDT, intermediate code generation. We have completed very quickly, but we have covered almost every concept. I can guarantee that 90% of the concepts are covered. 10% obviously I cannot help you in less time. Yeah, in this session we have so many kinds of optimization techniques like local, global, and for that you need to understand control flow graph and data flow analysis. Yeah, first we will talk about what are the optimization techniques. We have then how to construct the control flow graph, and one kind of data flow analysis, that is live variable analysis. I will help you. Yeah, Nikhil, I think so. Just look at the previous conducted sessions, you will understand. Yes, 12:15 I think. Code optimization. If you look at the code optimization, guys, why we apply the code optimization? Because either to save the time or space, or you want to reduce the cost of the program. Yes or no? There are various reasons the cost can be calculated based on time or space. So that kind of optimization can be done on a single statement or particular block you are looking for, maybe basic block that we talk about, or group of instructions. And some optimization can be applied on loop level. Only in loop you are looking for something, like you want to move the code from loop to the outside loop, or you wanted to eliminate some variables which are repeatedly used, or two loops are working similar, then you can combine them. And there are some other optimization function level. So within the function also we can understand the flow of the function, then you may apply some optimizations. And program level, between the functions also you can understand, you might apply on a whole program. Yeah, so various kind of optimizations we have. Basically we categorize into local and global, right? Local and global. But when you are applying, you need to focus on, are you applying on statement, are you applying on few statements together, or are you applying on loop or function or program, that you can also do manually. Yeah, in the exam you do not know what kind of questions that you are going to face, so you should aware of what kind of optimization that you can apply. Yeah, so these are the techniques that I am going to help you. This is very important for exam. Constant folding, basically that is possible to apply local, right? Because if you have a statement where you want to fold some constants, then locally possible. So this might help you to remember what are the local and global optimizations. Copy propagation might be applied in local or global. Some are backward, some are forward analysis, but don't worry much about now. But constant propagation can be applied locally or globally. Strength reduction is applied locally, and algebraic simplification also applied locally, and common subexpression elimination, it can be applied local or global. Again, dead code elimination mostly applied in global, because there you need live variable analysis. And loop optimization you need to apply in globally, because you are looking for more than one basic block there. Yeah, so in that loop optimization you will learn code motion, loop merging, induction variable elimination, loop unrolling. And please remember the names first so that you can understand each one one by one. Yeah, constant folding, copy propagation, again two types: constant you can propagate or variable you can propagate. Strength reduction and algebraic simplifications, common subexpression elimination, dead code elimination, loop optimizations. Yeah, we'll see one by one. Ready? Yeah. Tarun, good morning. PH, good morning. Is my voice audible properly? Tanya, good morning. Okay, let's begin. First one, constant folding. What is constant folding? It's a very easy optimization. Yeah, I'm just helping you how that gonna work. Suppose to multiply with 3 plus y. This is not intermediate code, this is high level code. And you know, the one thing, this code optimization techniques can be applied even different programming languages. Can be applied on high level programming language. high level code optimization, and many techniques are applicable in all of them. Some of them are only applicable at high level, not at low level. So this intermediate level, intermediate code optimization, where every instruction, let's say 3 address code, something like that. Another one, target code optimization. That is, the target code here is assembly code. Everyone? राहुल को हिंदी में कुछ प्रिंट करना है, कर सकते, क्यों नहीं कर सकते यार? Why can't you print in Hindi? You can. Anything you can do in the world. इंग्लिश ही नहीं आता इनको, हिंदी चाहिए यार. चलो, what is the constant folding? X is equal to 2 into 3 plus y. So what is the constant folding? This constants, 2 and 3. This one, 2 into 3 is 6. 6 plus y. What happened? We have folded 2 constants. This is called as constant folding. Where it is not possible to apply all the time, wherever it is possible, we may apply. Remember that. If not possible, you can't apply. Example, if you want, x is equal to 2 plus 3 into y. Here you can't do it because multiplication is highest precedence in C language. Now you can't apply constant folding. Constant folding not possible because 3 into y is applied, or multiplication is first here. So constant folding not possible now. Yeah, Nishu. Hi. Everyone. So this is a very simple one. In exam, they might ask, they might give you one program. They will ask what kind of optimizations you can apply. Everybody. And directly it may not be visible. After applying other optimizations, maybe constant folding is visible. And the order of optimization techniques is not known. Everybody, constant folding may be visible after applying copy propagation, or maybe after applying other optimizations. So which order you need to apply, really we do not know. Everybody? Chalo. Copy propagation. What is copy propagation? There are 2 kinds of copy propagations. One, we can propagate constant. Another one, you can propagate variable. Example, if you have x is equal, let's say 2, and I have something like y is equal to x plus z. This one you can write as x is equal to 2 and y is equal to 2 plus z. If you do that, sometimes even constant folding might be possible. Yes, sir, if z is some constant, already some constant, now look at that. If you propagate that, let's say x plus 3 is there. Now 2 plus 3. Now here you can apply constant folding, then you can write y is equal 5. Y is equal 5. Right, first you have done copy propagation, that 2 you have propagated wherever x is there, and now you can fold it. Here copy propagation I have used. And here you can apply constant folding. Yes, don't assume that they are visible all the time directly. No, they might be visible after applying other optimizations, like constant folding not visible directly, but after applying copy propagation, constant folding visible. Everybody? So now you might get the code x is equal to y is equal 5, and depends on the remaining codes. If x is not used anywhere, x is equal 2 will become dead code. If you are only printing a y, then x is equal to is dead code. That's later on I will explain. So understood the point? You can optimize, you can delete even x is equal to, because wherever x is there we have replaced with 2. So now you can delete this x is equal to, no doubt. That is called as dead code. There is no use of x is equal to now. Okay, I'm not talking about this one. So I hope you understood what is my intention, but I don't want to explain that way. I just want to explain how this constant is propagating. So now after optimization, apply what? The constant propagation. You will see y is equal to 2 plus z. This is the best code. Of course, I also eliminated x is equal to. You have propagated wherever x is there, you have propagated 2. And what is variable propagation? Suppose you have x is equal to a and y is equal to x plus z. So what can you do? Y is equal, wherever x is there, you replace with a. You can propagate variable 2. This is called as optimized code. Everybody, one, you are applying constant propagation, other you are applying variable propagation. Yeah. Clear? Now let's go for strength reduction. What is strength reduction? It's basically replacing costlier instruction with cheaper. Yeah, there are so many such things. Best example is, suppose you are writing 2 into y. But do you know that this can be written some other way? Multiplication is costlier. Everybody knows that. Multiplication is costlier. So I can replace with addition to x is equal to y plus y. I can replace with addition. Or even I can replace with shift. Y left shift by 1 bit is nothing but multiply by 2. Multiplication requires so many resources, it takes much time, but addition, it just requires 2 registers or 3 and it takes less time. Shift requires just 1 register. Yeah, this is called a strength reduction. I'm not giving many examples because, as you know, I want you to understand the word that you might require to use in the exam. In the exam, they will give you program. They will ask, can I apply strength reduction? Can I apply copy propagation? Can I apply constant folding? So that kind of questions will be there. So just you need to answer, yes, I can apply. They may ask you what are the optimizations are possible on the given code. So you need to choose properly. Okay, next, algebraic simplification. And strength reduction is also one of the algebraic simplification, but in algebraic simplification, you can have, some kind of cancellation loss. X is equal to identity also. You have y plus 0. Y plus 0. What you can write here? What you can write, guys? Just you can write x is equal to y. Later on, there might be copy propagation on this code. Identity. This is called as identity law. Everybody knows that. Y plus 0 is a y. Using identity property, you can apply this. Addition, not only addition, for multiplication also. If you have y multiply with 1, you can write x is equal to y. But that is identity for multiplication. Everybody? Yeah. If you have something like x is equal to y minus y, then you may write x is equal to 0. It's cancellation. Y minus y will get cancelled. It will get a 0. Everybody, it's a cancellation law. Similarly, if you have anything in algebraic simplification, you can easily apply because logic never change. When logic never change, you can do simplification. Okay, yeah. Clear everyone? These algebraic simplifications are also allowed in code optimization. Okay. Keep moving. Common subexpression elimination. You can use DAG if it is local, which is a simple expression, but if it is global, then you might require analysis. Like you require global code optimization, or whole program need to be analyzed. You need data flow analysis. And common subexpression elimination, you may use the DAG or you may use the data flow analysis. DAG can be used, or you may use data flow analysis. DAG can be used if it is only simple expression. If it is very simple expression, it's a local kind of optimization. Data flow analysis kind of global. So there is a technique called as available expressions. Available expression analysis. Using that technique, you can optimize code by eliminating common subexpressions. Example, simple one I am talking about. Yeah. Suppose you have x is equal to a star b plus a star b plus or multiply with b. Then what do? A star b is computed twice, so that you can compute once and you can reuse it. So the DAG is going to help you. A star b is computed twice. A star b is computed twice. Everybody? So you can do that. You may construct the tree for that if you want. And plus b, a star b multiply with b. So I am doing that first. And then addition is later, that a star b and this is a star b and a star b multiplied with b. This is the DAG. X is equal to, you no need to represent. Everybody, this is the DAG. But there is another technique, data flow analysis. If you have more than one expression, you want to analyze whole program, and then you can use the data flow analysis, where all the expressions in that function are going to be identified. If any expression is again used, then you can replace with the existing computation. Alright. This is called as common subexpression. What was the previous GATE question? Before 2016, this was in the syllabus. DAG is used for what purpose? Constant folding, copy propagation, strength reduction, common subexpression elimination. Then you need to choose common subexpression elimination. Yeah. Guys, please help the Garima Singh. And I can't reply everyone. Yeah. Dead code elimination. This is a very important one for the GATE, where there are two kinds of dead codes basically. There is some kind of statements which are unreachable, some kind of statements which are not useful. Example, look at, you have written x is equal to. I know where you have used x, suppose. You are printing y. If this is your code, have you used x is equal to? This is called as dead code. You can reach, but nobody using x is equal to. Everyone? X is equal to y, this is called as dead code because nobody using the definition of x. Then x is dead. Basically, x is not live. And live variable analysis is gonna help you here. For understanding dead code elimination, you need live variable analysis. Live variable analysis is going to help you to eliminate the dead code. There is another kind of dead code where you can see, you can write simply y is equal to a multiply with b and print y. This code is enough. X is equal to useless. Another one, suppose you have x is equal to 1 and if x print gate. See this code, you can use the constant propagation. If you propagate, this code will become, if this is always true, always true. If you have any else part here, will it execute? Will exam print? Always gate will be printing. So after applying constant propagation, after eliminating the dead code, you can simply write printf gate. Strength reduction also we did. The if true printf gate, you can replace simply with printf gate. You can do many things now. First you can apply constant propagation, then you can find out the dead code, you can eliminate it, and you can replace that if one printf gate, just printf gate, strength reduction. Yeah. Everyone? So it's very easy because you are the programmer, you can easily understand what is dead code. Dead code here, else part never be executed. So this part is called as dead code. This part is unreachable. Else part, this unreachable statement. During execution, it's impossible to go there. It is also dead code. Clear everybody? Dead code elimination. One kind of dead code is this one. Second kind of dead code is this one. This is reachable, but X is useless in the future. No one using the X. No use of X, you can say that. Okay. Now loop optimizations. Loop optimizations where you can apply some kind of optimization on loop level. Let's see how to do that. Suppose I have you are writing some code and you are writing x is equal to 10 and eliminate y is equal to y plus I, and you might have other code. You might have other code here. So look at in this code, it's in this loop itself. Do you know something is happening that is wasting your time? Can you see which code you can move out of this for loop? Still there is no effect on the programming logic. Yeah, this x is equal to 10. Every time you are making x is equal to 10, there is no use because x never modifies. No one using x. And here what you can do is you can move either above or below, because still above or below it will not impact the program because of in between no disturbance to x2. So you can move the code. I'm moving above, that's fine. But if I move it, what is the advantage of this program? What is the advantage of this program? Anybody? Because previously you were executing n times that statement move 10, that move instruction in assembly level. You can understand move instruction is executed n times. Now executed only one time. Everybody? Either move or you can say a load, something like that. Now loop merging. Very simple example I'm going to give you. Let me write a C program. Most of the time we write Suppose you have a program something like that. Everybody? Yeah, give me a second, guys. Just emergency call. Yeah. Hello, friends. Now we need to perform a loop matching. In loop matching, now can we match these two loops? I've not left anywhere. I'm back. Okay. What is loop matching? For can I mix, because both are repeating same number of times, so I can use one variable everyone. Can I mix? It's called as loop fusion or loop combining. Yeah, it's very easy. So that j, now this j we can replace with I. Previously it was j, now it is I. But it will compute the same logic. You will have same logic in both the programs. The only advantage is this second code will be executed very quickly compared to the first one. The number of instructions that you have executed in optimized code will be less compared to the given code. Yeah, so this is the advantage of loop matching. You can save a lot of time. So in the exam they might ask, they will give you this code, what kind of optimizations are possible. There are two optimizations are possible. One, loop merging. Another one, this can be done using strength reduction. 2 multiply with I. So I you can do left shift by 1 bit. So that is a strength reduction. So two things are possible. Strength reduction is there. Also loop merging is there. So they might ask how many optimizations are possible. Like what are the optimizations are possible. Everybody, here strength reduction also there, but depends on the question, you need to think about it. Alright, another one, induction variable elimination. Yes, induction variable elimination. So first, how many of you know what is induction variable? Let me try. Read the code properly. There are so many variables here, yes or no? Okay, there are so many optimizations might be possible. So many variables. Like I is one variable, j, n, x, y, what else? A. This many variables are there. Yes, Sveta. Yes. You need to do properly without changing the logic. Array, optimization possible only when logic doesn't change. श्वेता, अगर लॉजिक चेंज किया तो ऑप्टिमाइजेशन क्यों करना आपको बताओ. द लॉजिक शुड बी सेम. एक्स में जो पहले होगा अभी भी सेम होंगे, वाई में भी सेम होंगे. व्हेन देयर इज नो चेंज इन द लॉजिक यू कैन डू व्हाट एवर यू वांट इन द वर्ल्ड, बट देयर शुड बी एन एल्गोरिथम फॉर दैट. इतना इजी को ज़्यादा डिफिकल्ट क्यों बना रहा है. Performing optimization is difficult, but understanding optimization is not difficult, guys. Remember, using algorithm, if you want to do that, it takes even hours to understand. In the beginning, we are not using any algorithm. We are just looking at theory portion. Yeah. Now look at this many variables are there. Tell me, I is, everybody knows, induction variable. I is induction variable because somehow this I is gonna affect in some iteration, it is going to be updating. So I is induction variable. So what is induction variable? The variable which is going to depend on the iteration of the loop somehow. Now tell me, because of I, how many variables are induction here? Indirectly or directly? X also, Y also, because J is also going to update automatically, right? Here I, X, Y, J are induction variables. Here A and N, they are not induction variable. N never changes and A is 20, still that iteration, it can't affect the A is equal 20. You can move the code that A is equal 20 outside the loop. Everybody, so you can apply the code motion, you can apply induction variable elimination, right? If I change the little bit code, you can also get the strength reduction, but let it keep. Now we understood induction variables, right? So many induction variables here. Now can we eliminate any induction variable? Do you need really this many? Not required, right? So what I can do is, I'm going to eliminate J. Eliminate J. You are unnecessarily wasting your time for the J. It's a one loop only. We are not merging the loops. We are eliminating the induction variable. Eliminate J. Then what can you do to perform the same job? Same job. X is equal to X plus I, no change. But Y is equal to Y minus I you can do. Because IJ will have same values all the time. Then J plus plus you can delete. Because I plus plus can do the same job as J does. And A is equal to 20, keep it. If you want a code motion, you can apply it. Everybody, so you have eliminated J because J is same as I. No need two variables to perform the same job. Right? I and J are doing the same job. Clear? Everybody clear? What is induction variable? Sometimes induction variables are not possible to eliminate. That don't do that. It's not possible. Yeah. Next one, loop unrolling. What is loop unrolling? What is loop unrolling, guys? I am not worried about. You can move. अरे इतना क्यों सोच रहे यार? Later you apply code motion you want. We can also apply code motion. I'm speaking ना, समझ नहीं आ रहा है बात? We can also apply code motion. लिखना पड़ेगा क्या? करो ना अगर चाहिए तो आपको. मैं तो कोड मैं इंडक्शन वेरिएबल एलिमिनेशन समझा रहा हूँ आपको. लॉजिक हाउ टू अप्लाई इंडक्शन वेरिएबल मैं तो बता रहा हूँ ना. रिमेनिंग कैन बी पॉसिबल. अगर होगा तो अप्लाई कर लो. चलो नेक्स्ट, लूप अनरोलिंग. ये लूप अनरोलिंग खतरनाक प्रोग्राम है. लेट्स सी. I is equal 1, I less than or equal 4n, I increment, and this is, let's say, printf gate. And this one is actually gate is printed 4n times, right? 4n times. Only such kind of codes which will not impact the logic. Which will not impact the logic. Now, what is this unrolling? Unrolling, it means instead of repeating 4n times, you will do half of the time now. 2n. Printf gate. But this is wrong. Now I want to print 4n times. What should I do? What should I do? This 4n, you made it half. Then the job you need to make it double. The print you need to make it double. So make double. 2 times you are going to make. So what happens now? Same answer. Gate will be printed 4n times is same as the 2 times gate will printed 2n times. Everybody? Both will result same. Yeah, both will result same now. Clear? The advantage is the second code will execute quickly because you are repeating only 2n times. Yeah. So this is the faster code. This is the faster. So that's the advantage. Even I can go further. I can do one more time unrolling. This code I can do one more time unrolling. In that time I can do I is equal 1, I less than or equal than I increment. And now I made it off. I made it off 2n. I made it off. Then this code I'm going to make it double again. If I make it double, then 4 times you need to write printf gate. Okay, technically I am not talking about really this code faster or not, only in terms of loop I am talking about. Just a small example. If I assume printf gate is taking a constant time, number of iterations will be less. Clear? So this is one more time unrolling. 2 times when you do unrolling, you will get this code. Right? If n is even number, then still you can do n by 2, and even you can write 8 times. But it all depends on your optimization. Fine. So before going to other details, okay, let me help you again. In case if you are not aware of the new batch which is started by Unacademy, which is started on 18th June, and already 3 classes are completed and started by RBR sir, started Compute Network subject. 3 classes are already completed. You can join as soon as possible in case if you are preparing for GATE 2022. You can use my referral code DEVALIVE to get 10% discount. Yeah. So there is something like Peephole optimization, guys. What is Peephole optimization? Like code optimization you can also apply on the target code, on assembly code. So when you are applying an assembly code, you can't apply on whole program at a time. So what you do, you can do sometimes window, nothing but Peephole. You can gather, you can collect a few of the instructions of the program. So short sequence of instructions like move, add, subtraction, 2 or 3 or 4, 5, very few instructions we can keep one window. In that window, you can apply some optimizations. Like this kind of Peephole optimizations, you can apply on intermediate code also. Not only target code, you can also apply on intermediate code. So what kind of optimizations? Like redundant instruction elimination. Agar, you have already stored 10. Again you are storing 10 after some time. Then you can eliminate one of them. Without changing, same instruction is happening again. Redundant instructions you can eliminate. Flow of control optimizations. Like you are using so many jumps. You can write few jumps, or you can delete some of the jumps too. And algebraic simplification, you have seen identity. You can apply in the code itself, like add a comma 0. No need to do that because a plus 0 is always a. You can do simplification, right? Similarly, use of machine idioms. Then what are these? Okay. Yeah. In case if you want to know, you can search on Google. You can find out what are these and apply. I don't think they may ask about it, but still you need to know each and everything here. What happened? I less than or equal to. I didn't get you, Sweta. What are you asking? I can't help you. Fine. Okay, now we have very important topic, which is control flow graph. Flow graph is very important when you are analyzing intermediate code or target code. Both codes I am talking about, not one. If you want to optimize intermediate code or target code, you need a flow graph, because flow graph is going to help you to analyze the data in the program. So first we always draw a flow graph, or we understand the flow. We understand the flow. Then we do analysis of the data. So flow graph, either it can be control flow graph or simply flow between these statements. But control flow graph is one of the flow graph where we have basic blocks in the graph. So flow graph may be control flow graph or maybe simple flow graph, but difference is there. Flow graph you can draw as you want. You can relate the statements, you can relate the basic blocks, and as you want you can draw the flow. But control flow graph is a flow graph where it maintains the basic blocks. Then what is the basic block? The basic block is going to keep set of instructions which are going to be executed in a sequence. And the control only enters at begin, control, execution, and only leaves at the end. Control leaves at end. So control never enters in the middle of the block and control never leaves from the middle of the block. So control starts always from the first instruction. If you have like I1, I2, I3, then it starts always executing from I1 and I2, I3. Basically, I know the last statement of this basic block could be a jump, or could be the last block. Let's see. When you look at an example, you will understand. Okay. So now let me write a program. To understand the control flow graph. Let me write that. For I is equal 1, I less than n, I increment something. X is equal to x plus I. If x greater than 10, let me write a break. Otherwise y is equal to y plus j, I plus I, let's say, or multiply. Look at this code. How to draw a control flow graph. First you need to understand the control. So first you will understand the control. Remember that. You will start from here. You will go here. This is a control. You can say control flow, but it's a control for graph. We can't say, just flow. And you will enter here, or you will go out. So here you might be printing, let's say, x comma y, something like that. And after this, break. If it is really executes, break means it also goes here. If it fails, it comes here. And after executing this, it will go to the I plus plus, then I less than n. So have you understood this control? If you can understand this control, then control flow graph will become easy. Everybody, control flow graph also depends on basically 3 address code. You can use a 3 address code to build control flow graph, which will become easy. Okay, I'm going to write first 3 address code, then I will draw it. So I'm writing 3 address code, which will become easy. I is equal 1, then I'm going to check I less than n. If I less than n, then we are going to execute, right? If not, then we will jump. So I'll do if not. If not, how do you write? I greater than or equal to n. Then we say go to some statement. Let's say I will label it later. go to triple x, then if I less than n, we will come down, x is equal to x plus I. Here if x greater than 10, we will break. So we will jump some statement. If x greater than 10, definitely will go to which statement? Same triple x. Because it's just going to execute from wherever the for loop fails, exactly same place, that is after the for loop. Now y is equal to y multiply with I. Then इसके बाद you need to write again go to, but before that I increment. Then you can write go to triple y. So where is triple y should be? And that if statement, this is a triple y. Because we need to start from there. And what is triple x? You can keep here. You can write a print x comma y. First you should understand the 3 address code, which will become very easy to draw a control flow graph. Now you can see same control flow graph. We'll start from here, then here, and either we will go to triple x from here, or you will come down, and here also again go to triple x means either you go down or you will come to the same place. Triple y, you are going to start from here, or you can say this statement. Everybody, so I hope that you understood the 3 address code representation. Almost this is a 3 address code representation. Everybody, so now how to draw a graph? How to draw a graph? You need to put the statements in one block, like I is equal to 1 and I greater than or equal to n. I can't keep, because somebody coming to only I greater than or equal to n, so I is equal to 1 is alone. Now इसके बाद if I greater than or equal to n, go to, no need to write, you can show that where it goes, right? Go to triple x, we can go to triple x directly. So you can have a print xy statement here, and this one block, because only one statement is alone, here directly we can go there. If you want, you can go there, or you can come down. If it is true, if it is x less than n, I less than n, I less than n, you can come down, you can execute x is equal to x plus I. Now nobody coming to if, so I can combine this statement with, just a flow chart. You need to understand, but basic blocks are important. Now I am closing it because 2 controls are going out. One going to triple x, other going to if fail. If it is true, x greater than 10, it goes to triple x statement. Otherwise, it will start executing y is equal to y multiply with I is equal to I plus 1, and go to triple y. That you have to go to if here. Now look at, this is the control flow graph, and it is really difficult. It is really difficult. You are only practicing one example. You must be careful what is the control flow graph. Here you need to understand basic block. What is the basic block? Any block you look at, the control enters and leaves only after the last statement execution. Are you clear? Go to, no need to write, because go to nothing but a jump. Go to nothing but a jump here, unconditional jump. So all the edges here, whatever I have shown you, actually jumps there. If you look at this, all edges here called as controls, they are defined by jumps or go to statements, either directly or indirectly. Everybody? Yeah, in the exam they might ask how many basic blocks. How many basic blocks we got? 5 basic blocks. This is the very important question. But they may ask how many nodes. If they ask nodes, they might include start node, because that's not a basic block, and there will be end. After this one, there will be end. stop and start and stop. And here you can say 7 nodes. Everybody, 7 nodes. 5 basic blocks, 7 nodes. Got a point? But it's very difficult in the beginning. Which statements you need to keep together? You need to practice a lot. We already did the practice session. We do again. Especially there is one more session is going to come on code optimization, because a new topic, and maybe in one session I can't make you clear. You need many good examples to understand each and every definition. So I'll bring you one session only on code optimization, but it may take 1 week time because of other works. Yeah. Edges, if I ask, count the edges. Eight edges. Check, guys. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 edges. Among them, 6 controls. 6 jumps you might be using inside the program. 6 controls. Yeah. Everyone? Yeah, control flow graph is very, very important. Now, let's look at one example I'm going to do, that is a live variable analysis. Live variable analysis. This is the control flow graph, whatever they have given. It's a control flow graph. First, what is live variable? You must understand first what is live variable. Live variable can be computed at statement or at basic block or at or before after statements. That's, you need to be very careful. Live variable before something, before statement, after statement. These words are very, very important. Before statement, after statement, all this, just after, just before. You need to be very careful anything that they speak, but main definition we will compute at statement. Live variable at any statement. At any statement. You should be very careful. If you know the definition of this one, you can do for anything. You can do for anything. Yeah. So let me start slowly. Suppose I have a statement. Here, how many statements are there in this code? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 statements are there. This live variable you can compute at any statement. Remember that. At any statement. 10 statements. Everybody agree? We have 10 statements. You may number them if you want it. S1, S2, S3, S4, S5. This is S6 and S7, S8, S9, S10. So somewhere you are trying to compute, let's say X is not there. Okay. X is live at any statement. X could be any variable here. X is live at, let's say, statement I. If and only if there are 3 definitions you need to satisfy. Three points. One is, there exists SJ that uses, means that reads everybody, there exists SJ where SJ may be SI or maybe some other statement, doesn't matter. Second, there exists a path, at least one path enough. There exists a path from SI to SJ. SI to SJ. And third one, there is no intervention, means there is no write into X in between SI and SJ. In between SI and SJ, including SI and SJ. Remember that, everybody. So you should be very careful how to understand this definition. It's not at all easy for the beginners. You need to spend some time to get an idea. Yeah. So for that, I will be explaining one by one. So look at now. I want to compute who is live at, let's say, this statement. What is the statement number? SE8. So I want to compute same program I'm writing here. Here I want to compute who is live. This is, let's say, S8. S8. Compute live variables at S8. This could be the possible gate question. At S8, you might be asked, compute live variables at S8. So this is S8. Now, whenever you compute live variable, the future is important. Future point, future program point. Till the end of the program, you need to think about it. Is anybody using? Now look at how many total variables are there. You need to think about everyone. So from here, are you using A? So you have S8. S8 to S8, there is a path itself. You are using A. And no write into A in between because itself. So that means here A is live. Here A is live. Everybody understand? A is live because S8 to S8 is a path. But no need to be A is at S8. It can be even S9 also. Now look at another one. Another one. B is also same. Uses A comma B. So A and B both are live. There is another one is live at S8. Even C is also live because S8 to S9 there is a path and it reads, it uses C, and that is the reason C is live at S8. But actually it was used in S9, but you are saying that C is live at S8. You are not saying C is live at S9. That's a different question. Everybody, so here A is live, B is live, C is live. T1 is not live. Why T1 is not live? You are writing in S8 even though you are reading at S9. Everybody, you are reading at S9, but there was a write before S9 and after S8 including them. Everybody, T1 is not live. Remember, T1 is not live at S9 because which is changed. S8. So this kind of question expected in the exam and very, very important. Now I am going to ask one by one. Not this one. I am going to ask a lot of questions now. Let's see one more. S1. S1 is not at all easy right now. Yeah. But we can do exactly Pratiksha. There are so many good sessions are taken, but this is a Sankalp batch where I am focusing on to complete. But there are so many compiler classes already taken on this channel. You can also watch that playlist. Now I want to look at S7. Find live variables. Question will be like this. Find live variables at S7. So now look at what are the variables are live at S7. Can I say A is the live? Because A you are using at S7, enough. Don't look at any other statement. And B, is it live? You are using at S8. In between no write. T1 is not live because T1 there is a write into that. C is alive. That's it. Yeah, in future only A, B, T1, C are used, and among them A, B, C are live. Because S7 to S7 there is a path. Why A is alive? You can have two reasons, guys. S7 to S8 also. Why A is live? Why A is live at S7? Because S7 to S7 and S7 to S8, there are two reasons. One more reason. Who is that? S7 to S10 also there is a path because you are using A, you are printing A. So why A is live at S7? There are three reasons. Yeah. Everybody? Why A is live at S7? Because S7 reading, S8 is also reading and S10 is also reading. There are three reasons why A is alive at S7. They might ask the question, same question guys. In the exam if they ask which of the following is invalid reason, then the three options might be valid and here these three options are valid reasons. Valid reasons why A is alive at S7. Everybody? Yeah. Now, I'm going to ask one more question now. All variables are computed right at S7? Now, let me ask one different question now. S1, S2, S3, S4, S5, S6, S7, S8, S9, S10. Now, I'm asking about what are the variables are live at S6? Very, very difficult because of the loop. Actually, you need to perform the backward analysis, but I'm not doing it. Directly, I'm explaining. Raunak itself is a path. No need to show into the world, Raunak. You are reachable to yourself in the world. Should I show that Raunak is reachable to Raunak? Yeah, that is trivial. That is trivial, Raunak. अलग स्टेटमेंट है तो पाथ दिखा दो सेम स्टेटमेंट के लिए पाथ जरूरत नहीं है इट्स ट्रिवियल चलो जीरो मूव यार जीरो मूव इज आल्सो पाथ टीओसी में नहीं पढ़ी क्या ओके टेल मी गाइस फ्रॉम S6 what are the variables you can show live so that there is a some path if I S6 itself reading A right A is live because I can show that itself is a path. Itself, you are reading here, but after that you are writing, so no problem. And be careful, A is equal to A plus 1 means actually A plus 1 first, then writing into T1 and that T1 will go to A. Remember, A is equal to A plus 1 means first read happens, not write. Read first, then write later. Everybody? So be careful, A is equal to A plus 1. There are two things, read and write. But read only happens first. A is already live because you are reading before writing. So S6 to S6, this reads A. That is the reason. Okay. Next. What else you can say? M. Why M is alive? Because S6 to, you have S5. S5 reads M. बट S5 रीजन मत बताना ये के लिए बीच में राइट हो जाएगा और एनीथिंग एल्स गाइस बी ऑल्सो लाइव वाई बी होल फ्यूचर को देखना पड़ेगा वाई बी इज अलाइव व्हाट वाज द रीजन ओके लेट मी राइट द रीजंस हियर द रीजन इज S6 to S6 there is a path the reason is S6 to S5 there is a path. The reason is B के लिए S6 to S5 and which side you can go? S7 and S8. That means S6 to S8 there is a path. And C, same reason. Do you have a path S6 to S9? Here S8 actually using, right? S8 is using a B, here S9 using C. C is the live, T1 you can't show it, yes. A, M, B, C are live guys. Could be easy, but you need to look at all future of the program. From this point, you need to look at the future. The whole future you have to look at. The entire future. Any doubt in this? And this is the hardest question for the gate. In case if they ask anything about live variable, this is important. What are the live variables? Or how many live variables? Or if they say A is the live, what is the reason to be A is the live at particular statement? So these are the three types of questions are possible in the exam. Yeah. In case now I ask last trial for us. Yeah, this is S5. I'm asking why what are the variables are live at S5? Live variables at S5. Can I say that A is live, M is live itself? But there could be many reasons. Why A is live? S5 to S5 there is a path. There are many other reasons. S5 to even S6 there is a path. S5 to S7 and S5 to S8 and S5 to S10 also there is a path. So many reasons why you need to keep A is alive at this statement, because so many other statements you are using. If you delete here A, there is no meaning to other statements. That is the reason we say A is alive here, because you need to keep A is alive. Otherwise, those statements who are using A, they don't get a meaning. And M is live at S5? Yes, because M itself you are using at S5? Itself. S5 to S5. And what else you can keep? I can say B is alive, C is alive, but T1 is not alive. Again A, M, B, C. Everybody, why B is alive? Because S5 to S7 to S8. And why C is alive? That is S5 to S7 to S8 to S9. We always look at the future, we don't look at the past, so that you can easily understand what the variables are live. Okay guys, I hope you know a very short brief discussion about code optimization, but there are so many things to learn in code optimization, and I'm really not explaining many things like how to do the dead code elimination with the help of live variable analysis, and basically that is also there here. Yeah, sometimes dead code can be eliminated with the help of live variable analysis. And even copy propagation can be done here. You can see that constants can be propagated here. Yeah, we are not doing that analysis, but you can. So I helped you today to understand simple code optimization techniques where you can easily answer the exam point of view. This class is enough for the exam point of view. Remember, whatever the question they ask, definitely the explanation I have already provided here. But have you understood that explanation is a question mark. So I have taken so many videos on code optimization. I will keep on taking them because of new topic. Till you get a clarity, I will keep on taking, and I will also make you to practice them. Okay, please attend the practice session on only code optimization. I will conduct on some day on same YouTube channel. So we will do that. Okay, so see you guys till that time, and I hope you enjoyed compiler classes, and still there is a lot to learn in compiler too. And marathon on compiler is over, but practice sessions on few topics will come out soon, and our theory of computation marathon session will be going to happen soon in couple of days. I'm going to plan today, so I will announce that. Yeah, and from tomorrow we will start discrete mathematics. Okay, after this class, if you have any class like operating system is going to happen today at 11:30 AM, please attend the class. And in case if you want to take plus or iconic, please let me know. I will help you to take the subscription, and please use the referral code DEVALIVE. And this is the first batch we have started on Unacademy. Use the referral code DEVALIVE. And in case if you are not aware of the prices, you can see that for 2 years you have 39,600 for plus. Use the referral code DEVALIVE to see that price. And iconic, if you see 2 years, then 66,600. So you can choose as per your requirement, and we are always there to help you. This is my profile link, and please follow me, and always click on follow button once you visit Unacademy. That will help you to get notified of my classes. And this is our Telegram channel. Please subscribe to get daily material or daily links from us. Yeah, please share all these YouTube channels with your friends. And if any of your friends are studying in any stream like electrical, mechanical, electronics, civil, please help them. And please like the session and also share and subscribe. Thank you so much. And also don't forget to comment, which will help you, which will help us to reach more audience if you give good